All right. So, like I said, it's in the packet for today. We're in section 6.2, and it looks like this. All right. What section 6.2 is all about is inverse functions and relations. So you might have heard something similar to this concept before. Essentially, what you're doing with inverses is kind of flipping your x and y values. All right. And we're going to see a way for us to solve and find the equation of an inverse, just given one equation. We can find the inverse. We could also find the inverse given a graph and be able to kind of graph inverses as well. And we'll see some of the symmetry that they have and some of the different properties about those as well. All right. What I plan on doing is going through and just kind of showing a step and then using example 1 to kind of help us gauge how to do it. And then we'll go through a couple examples. This first page is just given an equation, being able to find the inverse. The second page is actually being given a graph, but we'll get to that a little bit later on. Okay. So steps to find the equation of the inverse. The first thing that we're going to do is take this function sign, so the f of x, or sometimes it might be given g of x, h of x, whatever it is. And what we're going to do is replace f of x with y. All right. So just a matter of taking one notation and changing it for another. Okay, and the reason that we want to do that is because we want to deal with an equation, not necessarily a function, because it'll help us go through and solve a little bit easier. So we'll replace f of x with y, and now this equation, if I'm looking at example 1, will be y equals 3x plus 6. So just changing notation. Okay. The next thing I'm going to do, as I kind of mentioned a little bit earlier, with inverses, essentially we are switching the x and y's for each other. So switch x and y. So I'm kind of flip-flopping where they are located in my equation, substituting them in for each other, essentially. So instead of y equals 3x plus 6, instead of y, I'll have x equals. Instead of 3x, I'll have 3y plus 6. Everybody with me so far? Any questions about either of the first two steps? The next step is to then go through and solve for y. So we're going to get a y equals equation similar to what we've seen in some other classes and earlier this year. But now our equation is going to look a little bit different because it's going to be the inverse of the original one. All right. We're going to use all of our different algebra steps that we've seen before. So we get rid of addition and subtraction first. We try to get that variable by itself. Sometimes we're going to have to multiply or divide. Might have to take the square root or even the cubed root, which we'll see a little bit later on. So all of those ideas will apply to what we're doing right now. Okay. So if I take a look at this equation, I'm trying to get y by itself. The first thing I want to do is eliminate any addition or subtraction. Well, I see that I'm adding a 6 over here. So I'm going to subtract the 6 from both sides. Okay. And when I do that, I'm left with x minus 6 equals 3y. So I've gotten rid of all addition and subtraction. The next thing I would want to do is make sure I get y entirely by itself. So I'm going to go through and divide both sides by 3. Well, when I do that, these 3's will go away. I'm left with y that's entirely by itself, and I'll have y equals x minus 6 over 3. I can simplify that a little bit further. And one thing that we talked about, excuse me, prior to the break was if I have a single term there in my denominator, whether it's a number or it could be a variable, what I can do is split up my numerator and divide each term in my numerator by that one singular term in my denominator. So instead of x minus 6, the whole thing over 3, I can have x over 3 and negative 6 over 3. And then when I simplify that, I'm going to rewrite this as just 1/3 x. It's the same thing. But now I can simplify the negative 6 divided by 3, which gives me negative 2. And not only do I have y entirely by itself, but I also have a simplified expression on the other side. Okay. Any questions about what I've done so far in this process with solving for y? So taking care of that third step. The very last step, so step 4, is to just go through, again, it's kind of a notation thing, and replace the y with f inverse of x. Now, the notation for inverse, a lot of times you'll see it'll be f, and then kind of raise it to a -1, almost as if it's an exponent. And then you write your x again inside parentheses. So whenever you see that notation, something raised to the -1, that is the inverse of that function. So instead of y equals, I'm going to write f inverse of x equals, but then my right-hand side stays the same. And I have 1/3 x minus 2. Anybody have any questions about any step along the way with that process?
Yeah, I got a question.
Sure.
So for y equals, so could you like either just leave it like that, or did you have to simplify it?
When I get to what step?
When you got to y equals x minus 6/3, could you have left it like that, or did you have to simplify it?
So technically, you could have left it like that, but I would simplify it as far as you can. So if
Okay.
you can combine anything, or if you can divide through, or maybe take out a GCF, just however you can simplify, I would leave it that way, because now I have a nice, like, neater linear equation rather than some kind of rational equation, which I might not know how to graph or things like that, because we'll eventually get into that. So I would go through and simplify it that way. Good question. Now, any other questions? All right, let's take a look at example 2. So again, first step, replace f of x with y. Really easy step. I just create a y equals x squared minus 5 equation instead of f of x. And then step 2, I'm going to flip the x's and y's. So it'll be x equals y squared minus 5. Everybody with me so far? Well, now, how should I go through and solve for y? If I want to get y entirely by itself, what would be my first step? Good. Add 5 to both sides. Just get rid of any addition and subtraction that I have, right? But now I have y squared. Well, y is not entirely by itself. How do I undo something that's squared? Take the square root. So I'll take the square root of both sides. Now, when I'm taking the square root of this left-hand side, I'm taking the square root of the entire expression. All right. But one thing that we need to remember whether it's one singular term or an expression like this, when I take the square root of something, just like square root method, this becomes plus or minus the square root of x plus 5. When I take the square root of a square, the y is left by itself. And this is as simplified as I can get with my expression. So always include the plus or minus, and make sure that when you're taking the square root, you take the square root of the entire thing on both sides. All right. You don't want to leave any terms out or forget to kind of simplify over here. Taking the square root of everything. Any questions up until this point? Last thing I'm going to do then, my last step is just to replace the y with an f inverse of x, and then my right-hand side still stays the same, so plus or minus square root of x plus 5. Any questions about that example? Yeah, you're fine. All right, let's take a look at example 3. So hopefully we kind of understand the process by now. What's the first thing that I need to do? Right, so change the f of x to a y equals. And I have a square root of x minus 5. What's step 2 tell me I have to do? Switch x and y. So now I have x equals square root of y minus 5. Good. The first 2 steps as you go through a lot of these problems should, be like second nature. Just change it to y equals and then flip-flop the x and y. The only really taxing part is to go through and now solve. So we have to kind of pull from all of our different algebra, rules and things that we've done before. I have the square root of y minus 5. It would be a lot easier if I just had y minus 5 by itself, right? So everything that's inside that square root. Well, how can I get rid of the square root on the right-hand side? So I will add 5 eventually, but I have to, the y minus 5, to add 5, it has to be kind of by itself. I still have everything inside my square root. So I will do that, but I have to get rid of the square root first. Think about how we took the square root of something squared, right? And it got rid of the square. So to get rid of a square root, what you can do is actually square both sides, right? You're kind of just doing the opposite of whatever that function is or whatever that operation is. And when I do that, I have x squared on the left-hand side. When you square a square root, it goes away. So I have y minus 5. Now what I can do is add 5 to both sides, as we said. And I'll have x squared plus 5 equals y. To get y entirely by itself. I'll give you a second to jot that down. And as you're doing it, does anybody have any questions about how we got to that point? Okay. Last thing I do is just replace the f inverse for y. So I have f inverse of x equals x squared plus 5. That's my final answer. Any questions about example 3? right. Example 4. Let's take a look at this. So I'll go through the same steps. This becomes y equals, instead of the f of x, I flip-flop the x and the y. So now I have y minus 8 squared is equal to x. Well, how am I going to get y by itself? What should I do on both sides to get that y minus 8 by itself, Jake? Right, square both sides. Well, what do I have to include on the left-hand side if I square the x? What should always be involved when I do the square root? You can think back to what we did in example 2 if you're having trouble. What should go in front of my square root? Good, the plus minus. So on the left-hand side, I'm going to have plus minus the square root of x is equal to, what happens when I square root something squared? What would be left over on the right-hand side? Just what's inside, right? The y minus 8. How do I get y by itself? Plus 8 on both sides. So I'll have y equals plus or minus the square root of x plus 8. Now, one thing to keep in mind also, when you're combining that 8 to the other side, you're not adding it inside your square root. So make sure that you leave that as 2 separate terms, right? You can't combine anything or include it under your square root. You still have the plus or minus square root of x as one separate term, and then you're adding 8 to that. Okay. Last step, replace that with f inverse. And then that would be your final answer. Okay. Any questions about that example or any of the examples that we've done on this first page? Any questions at all? Okay. We will do a little bit of skipping around just so we can get through everything that we need to. So I'm going to jump over to the next page. You will see questions like this on your homework tonight. It's actually the majority of your homework. Given an equation, can you go through and solve for the inverse? All right. Another type of question that you might see moving forward is actually being able to go through and graph an inverse. All right. Now, for whatever reason, just as a quick note, examples 1 and 4 didn't download properly, so you can go through and just kind of cross those 2 examples out. I want to get through 2 or 3 examples so we can see a variety of questions here, and then we're going to call it a day after we go through this process. Sound good? So how do we graph inverse relations? We'll do something similar where I'll give you a step, then we'll go through, take a look and use example 2 to kind of help us out with that. And then we'll just kind of keep going back and forth. The first thing that we're going to do is if we're given a graph, we're going to make a table of values for the, for the original graph that we see. So make a table of values. Okay. Essentially, all that means is we're going to take some points that are on that original graph and make an XY chart. I would say 4 to 5 points, and also take a look at that graph and kind of see where it crosses at certain integers, right? We don't want to deal with like -1.5, +2.25, right? We want to look at where it crosses at certain integers. So if I'm going through and I'm using this original graph over here for number 2, at -2, looks like I have a point at -4. So in my table, I'm going to write -2, -4. That was the X and Y value that I found just by looking at my graph. At -1, looks like I'm at -1. At 0, looks like I'm up at 2. So +2, so 0, 2. And then at 1, looks like I'm up at around +5. So I'm going to write down the point 1, 5. All right. Like I said, use about 4 or 5 points on that original graph to kind of help you out. And just write a table of values just to start with the original graph that we see. Any questions so far? The next thing I would do is go through and label your other graph or your other table as inverse, just so you can keep organized what your original equation was and what your inverse graph is going to be. And then very similar to what we did on the first page when we were solving with equations and we flipped our X and Y's and solved through, we're going to do the same thing now, but with our table. So flip the X and Y values in your table. Because when we flipped the X and Y values in our equation, that's what allowed us to solve for our inverse. But when we flip the X and Y values in our table, that's going to give us the points or the coordinates for our inverse graph. All right. So we'll go through. We'll create another table of values. Only now, it's just going to be the opposite. So instead of -2, -4, my X value is going to be -4, and my Y value is going to be -2. -1, -1 doesn't really change, right? It's going to be the same thing regardless. Instead of 0, 2, I'm going to have 2, 0. And then instead of 1, 5, I'll have 5, 1. So I'm just taking those values and flipping. Are there any questions about that process for step 2? Pretty easy stuff, right? Bless you. My last step is then to go through and plot the inverse points and then graph. So I'm going to take all the values in my table over here, plot those points, and draw my graph. Well, instead of being -2, -4, I'm at -4, -2. So my point is right there, my first point. -1, -1 was the same point, and that's okay. Sometimes your inverse might intersect. That's allowed. 2, 0 is another point. And then all the way over at 5, 1 is my fourth point. So I plotted all of my points. And now I'm going to go through and draw my inverse graph. there any questions about that process? So that's how, if you're given a graph, you would draw the inverse. Any questions at all? Yeah. So the vertical line test, yes. I'll get to that in a second. Good question. So that's the entire process of drawing an inverse. There's two other follow-up things that I want you to note. The first one has to do with symmetry of a function and its inverse, all right? If I were to go through and draw, I'm going to draw a dashed line as a diagonal through this graph, okay? That dashed line is the equation y equals x, right? If you plug in 1 for x, you get 1 for y. 2 for x, you get 2 for y. So it kind of has that just straight diagonal line property. Well, one thing that is unique about a function and its inverse is that I'll say a function and its inverse, and this is something that I want you to note as well, have y equals x symmetry. So a function and its inverse have y equals x symmetry. That means that if you take your original equation right there, that black shaded in line, and you were to reflect it over this line here, this diagonal, you get the inverse function. Or if you were to rotate it around, reflect, whatever is easiest for you to understand. That's how you get the inverse function. And that should be the case every single time that it will have that symmetry, right? Any questions about that? Just the property of inverses. The other thing that I want you to kind of bullet point or jot down, I just want you to write vertical line test. All right. What the vertical line test means is if you were to go through and take every x value, draw a vertical line through it. So all of these kind of dashed lines that are going straight up and down. And you were to do that across the entire coordinate plane, would you intersect the inverse graph more than once? If it only intersects that inverse graph once, then my inverse is a function. If it intersects my graph more than once, so it crosses through multiple times, then my inverse is not a function. So in order to answer this follow-up question, what you can do is, you don't have to necessarily actually draw a line, but kind of just go through with the other end of your pencil or whatever it may be, and just say, okay, well, I go through on this line, it crosses once, crosses once, crosses once. And you can kind of continue doing that through for every x value. Notice that it's only going to cross that line one time. When that happens, we say that that passes the vertical line test, in which case my inverse is a function. So yes, the inverse is a function. Are there any questions about that process or anything that we covered, even some of the follow-up questions? Okay. Let's take a look at example 3 then. We're going to go through and do the same thing. So maybe on this side, I'll make my x and y table. On the other side, I'll have my inverse. So it'll always kind of be set up the same way. First thing I need to do is make a table of values, right? That's my first step. So I'm going to take that original equation, the graph of that. I'm going to find some points on that graph. Well, like I said, choose about like 4 or 5. If I'm looking at this, At -3, I'm up around +4. So -3, 4. -2 looks like I'm at 1. At -1, I'm at 0. 0, I'm up at around 1. And at 2, around, I'm sorry, at 1, I'm around +3 or +4, it looks like. So about 4 or 5 points. What would be the coordinates of my inverse then? If those are the coordinates of my original function, what are the coordinates of the inverse of that graph? What's that? The opposite. So it would be 1, 0, and then 4, 1, right? I messed up when I was saying it out loud. I said 1, 3 instead of 1, 4. That's my apologies. But good. So the inverse, just like we did with the equations, take the x's and y's and flip them. Okay. Any questions up until this point? Okay. So now I'm going to go through and plot those points. So I'm at 4, -3, 1, -2, 0, -1, 1, 0, and then 4, 1. And this would be the graph of my inverse. Any questions about how I drew that or how I got those values, anything up until this point? Okay. So that would be a way for you to draw the inverse. Now I want, again, to kind of show you if I draw that dashed line again at y = x, I'm kind of just going through and sketching. Notice that it has that symmetry over that line, right? If you were to reflect it over y = x, you would get the inverse graph that we drew here. The follow-up question, though, is this inverse a function? Well, given this blue graph here, does it pass the vertical line test? If I were to draw a vertical line through that, does it intersect it once or does it intersect it multiple times? Multiple times. And when it does that, so if I go through, notice that it crosses here and here, crosses here and here, right? At a lot of points, it's going to cross multiple times. When that's the case, the inverse is not a function. Okay. Are there any questions about that example or that process in general? Okay. Just for the sake of time, I just want to show you what the inverse of example 6 would be, just to kind of give you another example of something that would not pass the vertical line test. So if you were to go through and kind of draw out the inverse of this, you'd actually have the points -3, 2, 0, 3, 1, 4, 0, 5, and -3, 6. Oop. Yeah, -3, 6. So this is what your inverse would look like for number 6. Just kind of drawing a rough sketch for you. Again, notice that it has that symmetry still, which should always be the case. It's actually a good way for you to check to make sure you drew the right graph of that inverse. But But then if you go through and you check all these points, notice that it crosses my graph at multiple points. So it fails the vertical line test, in which case it would not be a function. Question?
Since the original, I guess function and the inverse function in symmetry, can you just find the vertical line test for the original function?
So that's not always the case, because notice that in example 3, like this would actually pass the vertical line test right here. So at any point, I'm only crossing once. Right? One thing that you can do, because notice that if it passes the vertical line test, well, take the original function and maybe do a horizontal line test. And if it fails that, isn't the horizontal going to be the vertical for the inverse, right? If you think about the reflection. So if it fails that, then your inverse is probably going to fail the vertical line test, in which case it's not going to be a function if you want it to look ahead. But I would always maybe just verify that first before you go through and try and think too far ahead. Good question, though. Any other questions about this process or anything that we covered today, whether it was solving through an equation and finding the inverse, or actually going through and graphing the inverse? Okay. Well, let's take a look at tonight's homework then. Remember, we are in section 6.2. You're on page 396 doing numbers 15 through 25 odd. So when you're going through these, let me try. When you're going through these 15, 17, 19, 21, 23, 25, you're given an equation. So what you're going to do is flip the x's and y's and solve for y. Okay. And then you would find your inverse function the way that we did, right? Remember, you're replacing it with the f inverse. And then it says to graph. If you want to do like kind of a rough sketch of a graph, that'd be fine. You should be able to graph most of these equations by choosing some values. But for the most part, what I want you to understand is how to just find the inverse given the equation. So everything that we did at the beginning of class today. All right. Any questions about the homework for tonight? Okay, when you come in tomorrow, we're going to go over that, and then we're just going to do some practice of both the concepts that we learned today. Remember to keep in mind as well that if you go in the market period 3 folder, as I mentioned at the beginning of class, that extra credit is there underneath today's or this week's page. So make sure that you get that done if you want to receive some extra credit. Like I said, you can get up to 15 points, and that's due by Friday at midnight. I won't be accepting anything later than that. Okay. Everybody good? Okay. Well, then with that being said,